Okay, so hi guys. So in this video, we're going to be looking at how the services all connect together. How Django connects. Let me write that out. Django connects to our styling service built on DolphJS. Like this. How that connects to Redis and to our job worker, and conducts the algorithm, and the Gemini Vision AI, and then return the final results or the verdict. So far, I've explained the architecture of the styling service, the backtracking algorithm, and the retail compatibility system. But there's one piece that's left, and how it's the question: how do we connect all of these things together? How do they work together? That's what we need to look at, because the algorithm isn't the final decision maker; it's just a part of the process. So, and Gemini isn't the team that is generating every possible outfit either. So, the algorithm. Charis uses both of them for different jobs. The algorithm handles the structured search and the scoring, right? And Gemini handles the visual judgment. And BullMQ and Redis allows the expensive work to happen asynchronously in separate worker. So I want to actually explain why I introduced Gemini. We already know why I'm using Gemini Vision for the visual judging, right? But why didn't I just use Gemini to combine possible outfits together and bring out the best, let me say, 10 that are the final combinations? The reason I didn't do that is because AI credits are expensive, right? And if I say I want to use Gemini for the whole judging and then doing the combination and then the visual judging, it's going to be very expensive. So first I use something that is free, which is what the algorithm, and then on the top 10 that is going to be returned from the algorithm, I will then use Gemini to sort them based on the visual. I'll use Gemini for the visual judgment of them. So maybe we had maybe it was round 1, 3, 4, 5, something like this. So Gemini is now going to reorder them based on how well they put together visually. So that is why I decided to use an algorithm versus Gemini approach. So now, why do we need a blocker? So let me actually take it. So we have the job worker as a separate services of job worker, and so what's the index.ts. So this is a separate worker application. So you'll notice that this isn't the styling service itself. It's simply a separate process whose job is to consume the background jobs, right? So, and we have 3 different queues. The tagging worker. So the tagging is for analyzing wardrobe images. Okay. The combo generation is for generating and visually re-ranking the outfits, and then the verdict worker is for taking an existing outfit and asking Gemini whether it actually works visually. So we start them, and then we start all the 3 workers at startup and then close them on seek term or seek int. Okay. So what are BullMQ and Redis? I want you to imagine some flow like this. So DolphJS adds the job, right? So imagine this arrow. First, let me put Then, so DolphJS is going to contact BullMQ. Then BullMQ will contact Redis as BullMQ queue. So it's going to get added to, we're going to add a job to the queue, right? And then that will be sent to Redis and to catch it. Then the Redis is going to send that to the worker, the BullMQ worker, and then they will process the job. So basically, Redis is where the queued job data or data is stored, while BullMQ is the queuing system that gives us the structure for creating and consuming those jobs. So I don't manually write data into Redis and then manually check Redis every second. BullMQ handles the queue semantics for me. So Redis is like the underlying data store or the cache, and BullMQ is the job queue abstraction built around it. So the producer, let's take a look here. We're going to go back to the styling service now. And inside the styling service, we'll select structure and then the queue. So this is our producer here. This class. So its job is not to perform the outfit generation. Its job is simply to publish work for someone else to perform. That, oh, this came in, so this is what you're going to. It's going to contact what is going to perform it, right? Now, let's look at the combo queue and just let it queue. So we have a queue for the combination generation and one for the verdict evaluation. Then we publish the combo job, right? So here, this .add here creates the job and puts it onto the BullMQ queue. So the .add here creates the job and puts it on the BullMQ queue. So here you can see we've not imported any of the services, right? So what is simply happening here is that we're basically saying that, oh, here's some work that came in. So someone is supposed to process this later. So it creates two BullMQ queues, the combo generation queue and the verdict queue. So you do that while using Redis. You can see I've already hold it here. Yeah, this is just like normalizing the URLs, because the way I'm not running Redis on my system, right? So I'm using the Redis URL that's given to me from Upstash. So that's what it does there. Okay. So I activated the Redis here. Okay. So now, what is actually going into the job? Because you have defined some interfaces here. Let's look at the combo generation interface. So we're not exactly sending we're not sending the Redis is acting as the queue, right? It's performing the function of not the queue, sorry. Redis is basically just functioning as part of the queue. It's not. It's just helping us to store or hold the information temporarily, like about the job that is meant to be performed, right? So this is what we're passing. We're not sending a vague message like, oh, we want to do like a request combo generation. That's not what we're sending. Instead, this data here is what we're sending to the worker. We're not putting a vague message. We're not sending a vague message to Redis. We're sending it some actual structured data. So we're putting in the data that the worker needs. So we have the outfit ID, wardrobe items, and a couple of other stuff here. Right? So when the worker receives this job, it already has the context that is required to do the work. So now, where the worker actually receives it, I'm going to go back to the job worker and I'm going to go to combo processor. Okay, so let's look at the so this here is the consumer. So the name is combo generation, right? So this is the same queue that the producer was published to. So let me see here. It's the name of the queue. It matches. So then we have this. So this is the data. This worker extracts the data that we put into the job. So this controls the job. This is the actual worker. Then we have so basically what happens is that we add complicator add and then sends it to Redis and then to the worker, then it's going to be turned as job.data. It's going to be fetched here as job.data basically. Okay. So now let's see where the algorithm is added or where the algorithm enters. So let's go into here. So now the worker is going to call the styling service combo endpoint. This is the endpoint to generating a combo, right? Now this is not something we're going to visit ourselves, so it's just this endpoint is beautiful. Okay. So when I say visit ourselves, I mean like go to Postman. It's for the what's it called, the job worker process, or yes, the job worker process. So this is where the algorithm part happens. So the work self is not implementing the backtracking algorithm. It's asking the styling service to generate the best combinations for this wardrobe in addition with the context. These are the context. So basically, let me write it out. Basically, the worker visits that URL, that endpoint, then that sends to DolphJS. So DolphJS contacts the use case. Then the use case is going to include contact the backtracking, or put in the backtracking and the compatibility. It's going to call the backtracking compatibility scoring. That's going to return the ranked combinations, which will then be sent to the worker. So if you remember in the previous video, the backtracking explores the possible combinations, and then the compatibility scoring service scores those combinations. So then the result is going to be sent back to the worker. So now let's go back to let's look at this video. So top command. So So here's what I want. There's something here I want to specifically point out. So the algorithm gives us the combination, and the worker takes the first 10, right? So if the algorithm sends us the rank combinations, maybe that's like 20, we're going to trim that down to just the top 10. So let's look at this for loop. The worker here, the worker now goes through those candidates one at a time, right? Then image, this image URLs variable. So it extracts the image URLs belonging to that particular outfit. Okay. So Gemini is going to receive the text prompts, right? And the 3 images. So now what does Gemini actually do? So this is to show you, this is the block image URLs. So I'm mapping through it, finding the wardrobe item associated with the image URL. Okay, so let me show you the prompts. This is the prompt for Gemini. So these coding items are intended for blah 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 to work together visually. Check the pattern, the color harmony. So it's a pretty simple prompt, nothing too much. So the algorithm has already done the structured evaluation. So now Gemini is going to look at the actual images and judge it. So the algorithm only knows things like this is the top, this is the bottom, and the color scores are these, the formatting levels are these. So Gemini is going to look at the images and reason about the visual appearance together. So imagine that this is going to be what Gemini is going to send back to us. So confirmed is going to be true or false. The visual score is going to be between 0 to 100, so maybe like it's going to actually be 87, and then the visual note is going to be, oh, the calls work together, the pattern matches, it's not conflicting patterns, something like that. So now let's go and look at the Gemini. So I'm going to share Gemini things. Let's put this on. Okay, so let's look at for this variable parse, what it basically means, or what it does, or what it says, is that we're not going to blindly trust whatever string the Gemini sends to us, because if you use Gemini before, sometimes it can be a bit crazy with its responses. So you have to ensure that it doesn't cause your system or your app to break down. So we'll first parse the Gemini JSON. So we're going to turn the JSON text into a JavaScript object, and then we validate the combo visual results. So we're going to check that confirmed is a boolean, visual score is a value between 0 to 100, and then the visual note is a string. So the validation is already done in Gemini.ts with the validation for the verdict and the tagging responses. So this is important because TypeScript cannot magically guarantee that the AI API will return the shape I expect, even though I've already wrote it in the prompts. Okay, so this is the parse Gemini JSON. It's a helper function I've before. Okay, so now let me show you where the algorithm and the AI become one score together. So this is where the two intersect, where they connect. So here we go. So if the algorithm score was 82, for example, and Gemini's visual score is maybe 90, so 82 times 0.5, that's going to halve it, and 90 times 0.5, that's going to halve it as well. Then the final score is going to be what? 86. that's 41 plus 55. So then we're going to push I'm going to re-rank it, right, and push it into the re-rank array. So I'm not going to just discard the algorithm's info because we have a new because of the AI's scoring. We're going to put it together. So now the re-ranking, the re-ranked this line here, this is, oh my god, here, this line, this is going to sort them all over again. So let's say before the outfits, we have 3 outfits. We have A, B, and C, right? So let's say outfit A, according to the algorithm, was given a score of 91. Then B was given 87. Then C was given 84. But then Gemini ranked A to be 65, right? And B to be, let's see, 94. And then C to be 89. So after we combine it using this line here, after we combine the algorithm scoring and Gemini scoring together, the new value is that A is going to have a point of, say, something in the 70s. B is going to have a very high score of about, I think, 90, and then C is going to have 86. So before AI, the ranking was A, B, C, but now after combining, it's going to be B, C, B. Do you see the logic behind it? We ranked the outfits. So we have sorted it, and yes. So now the verdict part, let me just quickly show you what it does. So this is a second AI workflow. The first one was the Gemini Vision. Now this one is just going to be the text. So let's calm down a bit. What this is doing together. Yes. So we're not trying to generate 10 possibilities. We already have an outfit, right? And we're going to ask Gemini to judge it. So the response is going to look something like this. This is the prompt for Gemini, right? Ouch. So this is the response. This is how we want it to look like. The verdict, work, doesn't work, partially works, confidence, the string that explains why, and the pattern clash and color clash, if it exists. So what we're going to get back is going to be like, oh, the verdict, it works. The confidence, maybe 91. The visual note, it works quite well. It's fitted for this occasion and this season. The pattern clash, okay, it's false. Color clash, false. So the result you get back is going to be sent back to the styling service. So we already have a verdict worker that does this and marks the outfit whether it's done or failed, based on whether the processing, whether we get some errors from the processor files. Okay. So we have to complete this video. We have 2 job workers. We have the combo worker and the verdict worker. So the combo worker goes through the algorithm, then we get the top 10, we send it to Gemini. The Gemini visually scores it, then we combine them 50-50, then we rank them, send it to the styling service, and get the final result. Then styling service as in DolphJS, that's what I mean. Then the verdict worker on the other hand sends it to Gemini, sends it to verdict. So that is what we have all together. So the algorithm searches, the Gemini sees and judges, and then the worker makes sure to orchestrate it so that the workflow is synchronous. BullMQ and also Redis. Okay. So that is the end